Hello, and welcome to this presentation of NovaFlow's CyberMapper Aggregator, an SDN-based packet broker solution that is really exciting. So my name is Jeff Elpern. I'm the product manager at NovaFlow for this product. So let's get started. Starting at a high level, let's discuss the product. First, we believe that network operators and intelligent organizations are going to be very interested in this product because of the 6 attributes below. First, in the center top, is the agent pipeline. This is the secret sauce. It's an SDN solution out there, easy to use, very powerful, and what we're going to highlight. Right below that, a key component of the SDN solution is modularity. It makes speed of innovation and maintenance very easy. Now over to the right, we get the very high throughput, up to 6 terabit solution out there that is driven by, the workloads coming in on 5G. Below that, of ease of use, you got to be able to bring new people in, to craft these pipelines, to maintain them, to get the tap-to-tool flows going that you need in your current, in the modern network. Now, over on the left-hand side, very interesting. We have a number of clients coming to us and saying, my vendor has just stopped innovating. New things have shown up in the network, and they're not responding to them. And because we're an SDN-based solution, we've been able to do that, and we've been able to do that very, very quickly. And finally, all of this comes at a very competitive price point. Next, let's make sure everybody is totally grounded on where we fit in the network analytics environment. So we are in a taps to tools environment. We are right in the middle. We gather all the data from all the taps, all the spans coming in, apply the pipeline that sorts out who goes where, what traffic goes to which tool set, and then send it out to that tool set and load balances to the tools or mirrors everything to the tools in the tool sets. So we're right at the center here. Something that really differentiates us from our competitors is the NovaFlow software stack and the silicon we decided on to implement CyberMapper on. So the silicon is Intel's Tofino-based chip. It's P4 programmable. You completely design how the chip's going to operate through your P4 programs. On top of that, NovaFlow has the operating system, the NOS, that runs that. We have the runtime API sitting on top of that NOS that gets talked to. And then we have CyberMapper. So in this diagram, you see on the right that we own all the software between the application and the chip. And if there's something that needs to happen anywhere in that, for example, if the software needs a new feature in the NOS, we can do that. So that makes us extremely powerful out there in innovating at the cutting edge. Also, another area on there is that the Tofino chip has a very powerful parser in the silicon that we can control also, and that lets us again very rapidly deal with new technologies that show up. So the software stack is one of our killer advantages. Now we get to the core of the presentation, the CyberMapper Aggregator pipeline. We'll start a high-level view of it here, and the rest of the presentation will be drilling down on it a little more and a little more so we get a feel for what happens in each one of these, and then a very quick pass through to show you actual little coding stanzas, so how simple it is. So we want you to take away it's very powerful, but we also want you to take away that it's very simple. This graphic presents both the user-created pipeline and the infrastructure that enables that pipeline to be built. So first, let's talk about the infrastructure. Around the outside, starting on the left, we see ports. These are ports where feeds, coming in from taps or spans are, connected by a wire. So in this case, we're seeing 6 connections have been set up already, and arrows are going into the pipeline. On the left, we see 2 tool sets. These are tool devices sitting out there. So 3 in the Analytics 1 tool group and 2 in the A1 tool group. And then across the top, there we see the 4 stages that frame how the pipeline is set up. And this is the Ingress Group, the Ingress Filters, Egress Filters, and the tool sets. Now we'll talk more about these in detail in the next couple of slides, but that's the basic structure. Now we get to the user-defined packet processing. These are rules created by the user to identify what happens to the packets as they move through the system. So the 10 boxes in the center, starting with Egress 1, Egress 2, Egress 3, ending up with Analytics 1 and AI 1, are what we call agents, and they represent stanzas in the configuration file. The green arrows between the boxes represent flows. For example, on Ingress 1, we see that ports 1, 2, and 3 are all flowing into it. There they will get aggregated together, and they will flow out with the same identity from Ingress 1 or to Ingress Filter 1. Now, if we scan over to Interest 1, we see a slightly different process. Here you have, as the agent does its work, some of the packets flow to Analytics 1, and some of them get selected to flow down to Interest 2. So that's a basic diagram of how agents and the flow between them is represented. So this is a high-level graphics view of a user-defined pipeline that contained 10 agents, as defined in the configuration file, that generated 20 flows between them and out to the tools. Next, let's look at what happened in each one of the phases. The next 4 slides will present each of the key phases, starting with the Ingress Group. In each of these slides, we'll identify the main functions for that phase and the key features. For agents in the Ingress Group phase, the main functions are 1, the ability to combine tap streams that have similar flows, and 2, to provide an ID for the agent so that it can be accessed by the next level. The key features of an agent in an Ingress Group are 1, the ability to select one or more ports as flows coming in that group, and 2, the restriction that a port can only belong to one of the agents in the Ingress Group. Ingress 1 agent is a perfect example of how agents in this phase are commonly used. Here we have 3 feeds from ports 1, 2, and 3 being aggregated in Ingress 1. Now, the scenario for this would be 3 taps coming in from different physical locations, but all carrying the same type of traffic. And you would want to group them up so that all the rules you wrote after that, all the agents, all the processing you did after that, you would only do once, even though it was you had 3 sets of traffic coming in. So this is a great example of how Ingress Group agents make life better. So now we're getting into the really powerful agents. So the main functions for agents in the Ingress Filters phase are selecting flows from an Ingress Group stream. This is the same as before. We're moving up one and saying, hey, I want to get feeds from, in this case, the Ingress Filter 1 is getting it from Ingress 1. So just like before, we were getting them from the ports. So you're registering for what comes above you. 2 is filter the Ingress Group streams by matching on fields or packet shape. Now this is really pretty magical. So everybody matches on the fields in the 5-tuple or the or larger certain protocols. We also match on shape. So we can say, I only want packets that have MPLS depth level 1, regardless of what's in that header. But only one packets only have to have MPLS, but only have header 1. So that's that's the flexibility in the filter there. Then 3, we can stack these, and this example doesn't have a stack in it, but the next one over. So if you look at Ingress Filters, you can see 2 of them stacked. What that says is you can say, you can have a number of agents, 2, 3, 4, many, that say, I want to get, feed from the same Ingress Group above. But each one of them has a priority. And so the packets will come over to the highest priority filter first, agent first. And then if they don't get a match there, they'll drop to the second one, to the third one, so forth. If they do get a match, they'll go where the match shows. If they get all the way through the agents and don't match, they'll get dropped. But this is a way to get a flow, and we've seen tool sets that have 10, 15, 20 different types of tools, some of them very, very specific. This is a way to carve out those specific type of packets that you want out of the main flow and later send them off to another tool. So you can have a very sophisticated stack of rules. Hopefully they don't overlap, You always have to remember that the first match wins on this. So the third, the final one is an ID again. So whenever each agent gets their ID, so that the process, the phase below it can identify on that. The key features for agents in this phase are ability to register for the process above. We've talked about that. Filters, we've talked about that. Packets not matching, I kind of jumped the gun and we talked about that. But the new one, the really fabulous one, is the ability to mark this packet as having being encapsulated. So if it's a earthspan packet, we would mark it here, and then on the next phase, we'll be able to look inside. We'll take that mark and say, it's encapsulated. We'll be able to look inside at the real packet and make decisions on that. So this marking encapsulated packets is new and very, very powerful. Examples of how this simple pipeline may be using Ingress filters could be for Ingress Filter 1. Let's say that you had a lot of traffic coming in, but you wanted to drop out a number of things that had a certain profile. So you may want to cut your traffic in half, and you can do that by filtering on protocols and the 5-tuple, stuff like that. So that might be a pass here. Again, in Ingress 1, you could also be marking it, looking to see if this is encapsulated, and doing the markings on that. That would be a very powerful thing. So Ingress Filter 2 is an example of where you could be, you took the time to say there's something different between packets coming in on port 4 and packets coming in on port 5 and 6, and then you put them together. So the scenario in that might be that right now, those packets are different enough. Ultimately, there's going to be a new tool set, a third set of tools that will show up. But for present, you only have 2 of those, and so you're going to combine those at this pass of the pipeline into one filter. Give a name, and now you only have to downstream. You only have to have one set of rules, with the idea that you're going to come back later when you add more tools and then break that apart and have each stream coming out of Ingress 2 and Ingress 3 getting their own set of downstream rules. The egress filter phase is the most powerful phase in the pipeline. So agents in the egress filter phase have the following main functions. One, you can match on inner packet if the packet was encapsulated. And this is really, really powerful because we're not having to tear the packet apart. We're not having to decapsulate it. We're not having to do any of that to look inside at the actual payload and match on any of the headers in that payload. So that's what's given to us by having 2 phases here on the egress, where we look at the outer headers, and the ingress, where we look at the outer headers, and egress, where we look at the inner headers, if that exists. The second one is we can, if this is only a 1-header packet, we can use this for an and. We can take a second bite at the apple and say, I had a broad matching condition above me, and now I'm going to narrow that down on a second set of things. So for example, I might have matched on a packet shape above me, and now I want to say, it came from one of these 25 IP addresses, and really narrow it down. So you get a second bite at the apple, and think of it as an and condition out there. And then this agents in this group actually push the other direction too. They don't just register for stuff above them, but they push out to the tools. So this is where the replication engine sits. And you can send packets to more than one tool group, out there. And again, very, very powerful. We've seen complex environments where clients will be doing a match and then sending it to 10 or 11 different toolset groups. So very, very powerful on this. The key feature here are all things we've talked about before. So one, the filter on the inner packets. Again, we're getting at the actual payload packet inside of an encapsulated environment without having to deconstruct the packets. We get a second bite. Two, we get a second bite at the filters, so we can build very sophisticated 2-step filters on it. And third is we can stack again, just like we talked before, on saying that I've got 2, 3, 4, 20 agents all want to look at ingress filters above me, the same ingress filter above me, but you set them up in priority so the packets come over and go through the first one. If they match, they go out to where it matches to. Then they go through the second one, third one, fourth one, and if they get all the way to the last one and haven't matched, they get dropped. But a way to really dissect a big flow into many, many smaller, very tight flows. And again, we see clients that have big tool sets out there, and they may take a huge flow and break it into smaller flows that go to 13 different tools, 15 different tools. So in this simple example, the agents in this phase don't get exercised very much. But we do see an interesting case here where we had ports 1, 2, and 3 get all aggregated. They went through the first filter. They now go into the egress filter, and they get split up. So the architect for the pipeline has said, I want some of the packets to go off to my main analytics engine, out there, probably some security engine, but I want these special types, probably control packets, coming down, and I'm going to now carve them out and send them over to the AI engine out there and combine them with the stuff coming in on Ingress 3. The toolset phase brings the standard functionalities of the CyberMapper family to bear. This is the core of our product in managing large tool sets, doing HA, doing proportional load balancing to them, all of that. So agents in the toolset phase have two main functions. One, they can load balance to the toolset out there, or they can multicast to the toolset out there. And that's a choice that you put in there. Now, we didn't call it out on this slide, but like I said, it has all the other standard features of a full-fledged load balancer and making sure that dealing with failovers and all of that. The key features are, one, define tools within a tool set. Now, let's think about this for a second, because this is really, really powerful. All the processing in front of this defines how packets flow through this pipeline and arrive at, for example, Analytics 1. But none of those rules, none of that know how many tools are out there, and they don't have to. And what that means is that over time, you can start with 2 tools, move it to 3 tools, move it to 4 tools, and you don't have to change anything except that one agent that says, here's how many tools I have and here's where they live. The second feature is to be able to select whether you distribute the packets coming in on a load balancing across the tools or mirror them to all the tools. A way of looking at the pipeline built by the user is to use the Sankey diagram that tracks not only how does the packets flow, but the volume they flow through here. So we're going to use this interesting look at the pipeline to walk you through very quickly how each one of the agents are constructed, how simple they are, how straightforward they are to construct. So here is a code snippet, the stanza for Ingress Group 1, aggregating the 3 ports, easy to code, easy to read. Here's an example Ingress Filter agent filtering on MPLS depth 0. An Ingress Filter agent example, filtering on multiple rules and sending off the matches to toolset AI1. And finally, example code for the toolset stage. Here the agent is load balancing the 2 tools and sending it off. So we're at the end. Thank you very much for your attention. I know that's a lot to digest in a short period of time, and it's a pretty complex set of stuff to capture in a few slides. So again, thank you. So let's sum up with this, saying that the aggregator provides a powerful and unique technology for today's tap to tool mapping. That's what we're at the heart of it. It's easy to learn, easy to understand and maintain, which is incredibly important. We are very, very high-end throughput, terabit speeds, for the ever-increasing 5G volumes. And finally, we have all the features and more expected of any next-generation packet broker. Again, thank you very much for your time. Bye.